Hello, today we're going to take a look at how we can use systems of three equations in order to find a quadratic equation if we know three of the points. So for example, you might be given a situation where you have these 3 points. The point 1, 7, the point 2, 8, and the point 3, 11. Okay. And we want to find the quadratic equation, the parabola, that would contain these 3 points. So the first thing that we should notice here is that we have an x and a y. We've got 3 of them, 3 pairs of points, which is going to allow us to write 3 equations. So we start out with the standard form of a quadratic. Y equals ax squared plus bx plus c. Okay. And we can see we've got a couple of x's in there, we've got a y in there. We're going to replace those with the x and the y that are part of our points here. And we're going to do that for each point. So starting out with that first point, if we plug 7 in for y, and we would plug 1 in for x. Okay. Notice I use parentheses when I plug in the x values. That's going to be helpful if you have a negative x value that you're plugging in, making sure that when you square it, it comes out correctly. If we look at the second point, we have 8 for y, and then x is 2. And looking at the third equation, we have 11 for y, and we have 3 for x. So we just plug in the points. 1 point, 1 equation. Okay. Now it's probably going to be helpful to simplify these equations, get rid of these parentheses. So I'm just going to rewrite those down below. So 1 squared is 1, so I have 1a plus b times 1, which would be b, plus c. For the second equation, 2 squared is 4, so I have 4a plus 2b plus c. And for the third equation, I've got 3 squared, which is 9, so 9a plus 3b plus c. Now when we set up these 3 equations, it should be obvious that the easiest variable to eliminate here is going to be c. They all have the same number of c's, we just have to make one of them negative. So basically what I'm going to do is I'm just going to take this top one here, and I'm going to multiply everything by a negative. So it all becomes negative. Now, if I number these equations, 1, 2, and 3, I can go ahead and combine 1 and 2. Okay, so 1 and 2, if I combine those, negative 7 plus 8 is 1. Negative a and 4a is 3a. Negative b and 2b is b. Negative c and c cancel each other out. And then I can go ahead and I can combine equation 1 with equation 3. So equation 1, negative 7 plus 11 is 4. Negative a and 9a is 8a. And then negative b and 3b is 2b. And the c's again cancel each other out. So now I've gotten it down to 2 equations with 2 variables. Now I need to solve for one of the other ones, and it should be apparent that b will be easier to get rid of here because we can just multiply the top equation by a negative 2. Okay. So if I multiply that top equation by negative 2, I get negative 2 equals negative 6a minus 2b. And now when I combine these 2 equations, 4 minus 2 is 2. 8a minus 6a is 2a, and the b's cancel each other out. And then I just have to divide by 2, and I get that a equals 1. I've solved for a, now I need to solve for one of the other variables, so I come back up to one of these 2 equations and I plug a in. I'll use the first equation. 1 equals 3 times a, which is 1, plus b. So 1 equals 3 plus b. subtract the 3 over 1 minus 3 is negative 2. So b equals negative 2. Now I have a and b. I just have to take those, go back to one of my original equations, and plug them in to solve for c. I'm going to use the top one, but without the negatives. So I have 7 equals a, which is 1, plus b, which is minus 2. Oops. And then plus c. Okay. Now, I just need to simplify this, so I apologize here. The computer was thinking a little hard. 1 minus 2 is negative 1 plus c. Add the 1 over, and I get 8 equals c. So now I have a, b, and c. But in this case, I don't just want to know what a equals, b equals, and c equals. I want to write the equation for this parabola. So I'm going to go back to my standard form here. I'm going to plug a, b, and c in. So y equals, a was 1, so 1x squared. I can just write as x squared. Plus bx. B was negative 2, so plus and negative is going to be minus 2x. And then plus c. C was 8, so plus 8. Okay. And that is the equation of the parabola that goes through those 3 points. Okay. Now, you may want to come up with some problems on your own to try. So what you could do is you could go to a graphing calculator or a site like Desmos and type in an equation. For example, y equals 3x squared minus x plus 7. Okay. And so you just make up your own equation. It doesn't matter. You choose an a value, a b value, a c value. And then if you click on the little gear here, you can edit the list and you can turn it into a table. So if I convert this into a table, now I have some points I can use if you want to add more points. For example, 3 would be 31. And you just pick 3 of those points. Any 3 of the points that you want. I would recommend avoiding 0 for x, but any of the other points, just pick 3 of them, and then you've got your 3 points that you would need, just like we started out with here. Solve it, plug them in, solve for a, b, and c, and in the end, when you get your equation for your parabola, you already know what the answer should be. So it's an easy way to check and make sure that you're getting the correct answer, and an easy way for you to come up with your own problems that you can try. A lot of times, people want extra problems to practice. Here you go. You've got an easy way to find extra problems that you can practice. So that's solving a system of 3 equations in order to find the equation of a parabola. Now it's possible that we could put this into a context of a word problem. All you have to do in the word problem is, again, find 3 points within that word problem. Find an x value and a y value that go together. Find 3 of those. Write those 3 points down. Plug them into your standard form for a quadratic, and then solve. Okay. So again, solving systems of 3 equations in order to find the equation of a quadratic that goes through those 3 points. Thank you.